Hi friends, see in gravitation part 1 we have studied about the value of g, how it is varying due to altitude and depth. Today in part 2 gravitation we will be dealing about latitude. Okay, so in gravitation part 2 we will be dealing about latitude. So latitude valla, ante in latitude in some books they are giving lambda or phi. So due to latitude, what happens to the value of g? Okay. So as we know, these are the directions north, south and east, west. And if you see the configuration of the earth, this is the earth configuration. This is north, south, east and west. We all know how the earth is rotating. See, it is rotating in this fashion with an angular velocity omega from west to east, running from north to south. It is moving from west to east, running from north to south. So suppose if this is the radius r, let a particle or a body is at here, at this point, latitude. Let this angle be some lambda or phi. Let this angle be lambda or phi. Anything you can consider. This is latitude. So here. So at this point P, suppose try to draw another line. Now the new radius is smaller. Now you can see the new radius is smaller. Now if you see here, what happens? At this point the circle is the radius of r. It is rotating at this point with a circle of radius r. Okay. The same way you can take one more point with same radius r. So this is the rotation of the earth. In this fashion it is rotating from west to east. You can see it is rotating like this. So what we have to do is we have to find the value of g, how it is affecting due to latitude. Okay. Now let us learn some points here. Now the body is at point P. Now when the earth is not rotating, suppose not rotating, okay, suppose when the earth is not rotating, what happens here? The weight component of that body will be towards the center, W. When the earth is not rotating, the component will be towards the center. But when it is rotating, here centrifugal force will be acting outside. See here, okay. This is the centrifugal force, Fc. Fc is equal to mr omega square or mv square by r. In terms of linear velocity, it is mv square by r. Okay, mv square by r or mr omega square. But here at this point, the radius is what? Smaller, not capital. So we will put it as smaller. Mv square by smaller, where r is the radius here, where it is making some circle here at this point latitude. Now this is lambda or phi, this is also phi, vertically opposite angles. If this is phi, this is also phi. So from this you can calculate what is small r. Small r is nothing but what? Adjacent by hypotenuse. R by capital R is equal to cos phi, or small r is equal to r cos phi, equation 1. This is the radius of the circle at the point P latitude, how it is rotating with the circle. Now since it is rotating, it is having some centrifugal force acting outside, mv square by r or mr omega square. Now if you extend this line, okay, if this angle is phi, this is also again vertical opposite angle phi. Now what is the component of the centrifugal force in this side? Fc cos phi. Fc cos phi and mr omega square cos phi. This is the component. Okay, this is adjacent component, this is vertical component. Okay. Now here if you observe, when it is rotating, what is the net weight? Net weight will be around this direction, W dash. Before it was at rest. Rest lo undi kabatti weight toward the center. Because the earth is rotating from west to east, running from north to south, the component of centrifugal force is in that direction. So this will be lesser than this force. So what is the net weight? So when it is rotating, the net weight ఎంత అవుతుంది? See here, net weight of the body, net weight is given by weight at rest W minus component of centrifugal force, that is mr omega square cos phi. This is the net weight, which is equal to what? W dash. So therefore net weight mg dash is equal to mg minus m. What is radius here from equation 1? R cos phi into omega square cos phi. Therefore cancel m on all the sides, taking common. G dash is equal to G minus what is left over here? R, okay, omega square cos phi into cos phi, cos square phi. Okay, so cos phi into cos phi is cos square phi into omega. So this is the general equation due to latitude. When the earth is rotating, okay, when it is spinning on its own axis, the new acceleration due to gravity, G dash is equal to G minus something. ఇక్కడ G minus something అంటే R radius of that 6,400 kilometers, omega angular velocity, cos phi the latitude. So G minus something అంటే అర్థం ఏంటి? 9.8 లోంచి subtracting means the value is decreasing. Therefore due to latitude, this is also IP లో 4 marks derivation intermediate. So in this fashion, if you derive it easily, you can get 4 marks. Therefore G value decreases due to latitude. Latitude in some books they are following lambda, or in some books it is phi. Anything you can make it. So this is how you will be deriving for the value of G due to latitude. Now there are some corollary, please copy. Now suppose if phi is equal to 0, if phi is equal to 90, we will comment now. Okay, so this is the derivation for latitude. Now by using this equation, we will see what happens to the value of G at poles. That is the fourth point already I have given in you in part 1 gravitation. Part 1 gravitation lo meeku already konni ichanu kada, how the value of G is affecting. Value of G is affecting due to latitude, due to height, depth, okay, that also equation given. And third one is due to latitude, G dash is equal to G minus something, R omega square cos square phi. Fourth point already I have discussed, that is due to poles and equator. Fourth point em cheppanu meeku, due to poles and equator. You can say this is north pole and south pole. As we see the geographical features of the earth is flattened at the poles and bulging at the equator. Poles దగ్గర బల్లపరుపుగా ఉంటుంది, it is flattened generally. So when it is flattened, G will be more. You can see here. See the angle here. Now it is making phi. Now what is the angle now at poles? It is making 90 degrees. So when phi is equal to 90 degrees, okay, when phi is 90, what is cos 90? Cos 90 is equal to 0. So cos square 90 is also 0. So when 0, cos 90 is 0 kabatti, what about this value? This entire value is cancelled. Cos square 90 kuda 0 అయిపోతుంది, 0 into R omega square 0. So G minus 0 G. So what is G dash? G dash is equal to G. That means at poles, north pole and south pole, G values will be same, 9.8 only, because the angle making there is 90 degrees, cos 90 0. Because it is 0, this entire thing will be cancelled. So G value is more. Adotna, it is flattened at the poles, G value is more at the poles. Now coming to equator. Equator, if you come to the equator, see, what is the angle now? 0 degrees. So at equator, phi value is taken as 0 degrees. You can see it is parallel to this one. So what is cos 0? 1. So if you put 1 here, cos square 1, again 1 into 1 1. So what is G dash? G dash is equal to G minus R omega square cos square 0 degrees. Since cos 0 is equal to 1, you put it 1 value here, G dash is equal to G minus R omega square into 1. Therefore G dash is equal to G minus R omega square. Again you can see here G minus something ante value malli taggipotundi. So at equator, because of the bulging nature, geographical features, the value will be less compared to the poles. These points are very very important in the entrance examination like MSET and NEET, and IP will be asking for 2 marks questions. Okay. So G value is more at the poles. Proof is also given from the equation. G dash is equal to G minus R omega square cos square phi, and it is less at the equator because of the bulging nature. You can see 0 degree cos 0 is equal to 1 kabatti. When you put value 1 here, so the G minus something, the value is decreasing. Clear? Okay. Now these are the things or parameters affecting the value of G. Last one also sometimes you will be asking, the fifth one, that also you can write down. That is due to some deposition, mineral deposits. For example, scientists are given some instruments, that is like we have some sensitive instruments, sensitive devices or instruments like E2Os and Boliden, gravity meters. These are the devices developed by scientists. One is ETWOS gravity meter, Boliden gravity meter. When you take at certain places where you have to find out the G value, small g value, due to mineral deposits, then slightly it was observed that value was some increasing or decreasing. And the G value is found around 9.74 meter per second square, or sometimes it may be 9.6, or sometimes it may be 9.8 and 9.9 also. So the value will be varying. How you can find out? Normally you cannot find out. So you have to take these devices at that places where the depositions are there, like minerals or rocks. Then you can see the value was found to be slightly varying. Lesser value like 9.7 or 9.6, or sometimes it may be more value also like 9.9 meter per second square. So these are the things, values, parameters affecting the value of small g, acceleration due to gravity. Very, very important regarding IPE and also in the entrance examination like MSET and NEET examinations. Okay.